In this video, we're going to discuss about the premise of calculating the net present value for a particular project and evaluating whether it makes sense to invest in the project or not. Some of the key terms that would come here would be in the context of net present value and internal rate of return, right? Now, we have already seen how do we go about trying to find the present value of a particular set of cash flows. And the primary idea of that was to actually figure out what should be the value that we should be willing to pay to kind of get entitlement to a set of cash flows that's going to come in the future. Now, obviously, because the set of cash flows is at different points of time, to arrive at a sort of similar understanding in all these cash flows, we have to convert all of these to present values, right? When you convert all the cash flows to present values, then effectively what is happening is, let's say there is a cash flow 1, there's a cash flow 2, cash flow 3, cash flow 4, and you're making an investment today which is a cash flow 0. So this is the investment that is made, and the other 4 are the returns. Obviously in time you can't compare them correctly, right? So 1,000 here is not the same as the sum of all these being 1,000 in the next 4 years. You would not be happy with that, right? So you want to convert it to present values. What does present value do? Present value brings all of these cash flows to the same time point. All of these cash flows, once you have identified the present value, come here, where a normal summation or a sum of these cash flows can tell you whether it makes sense to invest in the project or not. So conceptually, what we are trying to do is we are trying to equate the cash flows, or in other words, there is an uncertainty that is there with the cash flow being in future. We are trying to remove this uncertainty, right? We're trying to remove this uncertainty by bringing the value of the cash flows to today's point. And once we do that, it is comparable to the investments that we are going to make today. And we can then do a simple mathematical calculation to try and find out whether it makes sense to pay 1,000 today for something that is going to give me 1,200 tomorrow, right? Obviously, this includes the component of risk on these cash flows. What is the risk on these cash flows will define, so what is the risk will define my expected return on these cash flows, and my expected returns would define what is going to be the discount rate, right? My expected return is going to be used here in terms of 1 plus r and 1 plus r square, and so on and so forth. When we find the present value of all the series of cash flows for a particular project and add them to the initial investment, which would essentially be negative, and we find the value of the entire project, that is what is termed as the net present value of that project, right? Let's understand the definition. Net present value of a project is the present value of the cash inflows minus the present value of the cash outflows for a particular project, and it is it is the value that will define whether we should take the project or not take the project, right? If there is a scenario where you are losing money on a project, that doesn't make sense to be taken. But if you do make money on a certain project based on the parameters that are there, it would make things simpler and easier for you if you were to take that project, right? There's another term called internal rate of return. We will just come back to this in a moment. Some of the other terms that are important are payback period and discounted payback period. We will also discuss about these as we go along. Let's look at an example. And as we look at an example, it would make things clearer for us in terms of our overall understanding. So let's look at a project that requires an initial investment of rupees 5,000 crore today, and it returns rupees 3,000 crore, 2,000 crore, and 2,000 crore in the next 3 years respectively, right? So you invest 5,000 crore today, and you get you get you get these 3 series of cash flows, right? Now, investment means negative because money is going out. That's an outflow. And these 3 set of cash flows are inflows for us, right? And that's our decision point. Now, on the naked eye, prima facie, you put in 5,000, You're getting 3,000 plus 2,000 plus 2,000. That's going to be equal to 7,000 in simple terms. That seems good. But the reality is that these are later in time. This is at the end of first year, this is at the end of the second year, and this is at the end of the third year. So their value is not the same as 7,000 today. To get that value, you'll have to divide this by 1 plus r, you have to discount this by 1 plus r square, and you'll have to discount this by 1 plus r cube, and then add the 3 to get what is the value of these cash flows today, right? What is the expected rate of return? That's 10% based on certain calculations. At this point of time, we're not getting into the detail of how do you do this calculation, but let's assume that whoever is investing in this project wants a 10% return. At that, what is going to be the present value of this entire set of cash flows is what we're going to look at. Let's go to an Excel file and try and understand it there. So this is our series of cash flows that we just saw, and we have invested 5,000 bucks, and 3,000, 2,000 and 2,000 is what's going to come in. We are saying that effectively I have to discount this by 1 plus r, discount this by 1 plus r square, discount this by 1 plus r cube, and then add the initial payout to see whether I make money on the project or not, right? So let's do that. Let's do this calculation. I'm going to find the present value of 3,000 divided by 1 plus 10%. I'll freeze 10% so that I can drag the formula on the right side, raised to the power 1. The first cash flow will be discounted by raising it to the power 1, the second one power 2, the third one power 3, right? What is the sum of these discounted cash flows, right? So the sum of these discounted cash flows is the sum of these three. So we make 5,883 in present value terms, right? In present value terms, we make 5,883. And what that does is essentially tells us we should take the project, but this is just the present value of the cash inflows. We have not taken the present value of the cash outflow. So to get that, we'll have to use this plus add this minus 5,000 as well. 883, which means if we take this project, there is a positive non-zero value that is generated for the company. You pay 5,000 and you get 5,883. So in the sense, if NPV is greater than 0, you should take the project. If NPV is less than 0, you shouldn't take the project. Let's say the company was raising money at 15%. Even then you should have taken the project. If the company was raising money at 25%, you see NPV turns negative. Now, if your expected required return is 25%, you would not take this particular project because this gives you negative cash flows, negative present value terms value if you get into this project. Prima facie, it appears you're making 7,000 and you put in 5,000, but if the cost of that 5,000 was 25%, then you're not so good in terms of investing into this project, right? Let's go back to our initial set of data. We can also solve this using this function called NPV, where it'll ask you for the rate and it'll ask you for the set of cash flows. Remember, NPV assumes that the first cash flow is happening at the end of the first year. So you start from 3,000 and then you add the initial outflow that has been done. That's 883 once again. So you could have also solved the same question using the NPV formula on the Excel file to arrive at this value, correct? That's the NPV value. That's the calculation of NPV. Now, let's move one step further and try and understand what happens if we look at these terms called payback period and discounted payback period. Payback period is nothing but the amount of time in which you get your money back in absolute terms, right? Discounted payback period is amount of time in which you get money back in not absolute terms, but present value terms. Now think about it. Sometimes decision making could be on the basis of payback period. There's a manager who says, I want my money back in 2 years, right? Now, what is the payback period here? You put in 5,000, you get 3,000 in the first year, you get 2,000 in the second year. That means you have recovered your money in absolute terms by the second year, right? So the payback period here is 2 years. right? Now, that doesn't help because honestly, you still have not made money in present value terms. Payback period might be useful in just giving a broad, simple understanding on whether the money comes back or not. But the moment you put the present value into the picture, that is not so rosy as the picture, right? So it doesn't come back as quickly as we thought it would. Discounted payback period would find out in present value terms when do you get your money back. So for that, we'll need the cumulative cash flows to be seen. So let's say cumulative cash flows, we started with minus 5,000 and you add 2,727 to that. So you're still outstanding with negative 2,273. To this, you add the present value of the second year, you're still outstanding 620. Now, you want 620 more, and in the third year, you're getting 1503. So effectively, 620 divided by 1503, assuming the cash flows are uniform during the year, in the third year is what is going to be added. So 2 plus 620 by 1503 is the number of years that will come in discounted payback period. So that's 2 plus, I'll put a negative here because that 620 is negative, divided by 1503, 2.41 years. Effectively, approximately 2.41 years worth of cash flows in present value terms give me back my money under the discounted payback period concept, right? Now, these concepts are important because, again, we are trying to figure out when do we get our money back, and that's what a discounted payback period or a payback period talks about or tells about, right? So that's essentially how we go about solving this question for NPV and trying and finding out what is the net present value for the company's for the cash flow for a particular project based on a certain rate at which you are trying to discount the cash flows. So the key parameter that is available here are there are two parameters. One is obviously the set of cash flows. The second is the discount rate that you're going to use. Here we have assumed that the discount rate is given to us, right? Let's go ahead and try and get more data points around internal rate of return, right? Now, the minimum return required to cover the investment cost is called the IRR, or the internal rate of return. In other words, you could also look at it as the maximum rate at which you can borrow to invest in the project, right? I'll go back to the initial discussion as well. Rate at which the NPV of the project turns zero. At rates higher than the IRR, the project will not be feasible. Simply put, IRR is the maximum return that can come from the project. I mean, this is given as the maximum rate at which you can borrow the money for a particular project. Let's go back to our initial example. Now let's recalculate the data here. IRR can simply be calculated by using the function IRR, and you just put in the set of cash flows into IRR, and that tells you what is the IRR. We get the value 20.64. What does IRR tell us? 20.64 is the point at which the NPV will turn zero. So if I put 20.64% here, you see that in our calculation, the NPV becomes zero, right? Any rates, if you borrow beyond this for this particular cash flow, any rates, if you borrow beyond this, your net present value will turn negative, which means if your IRR is if your cost of borrowing is greater than the IRR, then essentially you don't invest into the project, right? Because at those rates, NPV will become negative, right? So let's rewrite this set of rules. What we are saying is that if you're looking at a project, if NPV is greater than zero, accept the project, right? In other words, if your discount rate is less than IRR, accept the project. You will note that both of these would correspond to the same result in the simplistic format, right? If your cost of discounting or cost of getting the money is less than the IRR of the project, you will have a positive NPV. So both of these would correspond to each other in the context of simplistic projects that we have seen so far, right? That gives an idea on how do you actually look at calculating the NPV and the IRR? And beyond the IRR, it doesn't make sense to borrow money. If a particular project's IRR is defined as 15%, there is no point in borrowing money at a rate higher than 15% because you will not be able to make money on that project, right? If you borrow money more than at 15%, then essentially this is what is going to give you the data in terms of how the IRR functions, right? Let's take another example and let's look at a calculation here. Your firm spends rupees 5,000 and receives these cash flows over the next few years, 1,000, 2,000 and 3,000. Assuming a rate of discount of 8%, right? 8%, let's say, is your expected rate of return. Can you calculate what is the present value? So you discount 1,000 by 1.08, 2,000 by 1.08 to the power 2, and 3,000 by 1.08 to the power 3. When you add all these up, the summation of all these present value terms done give you the NPV, which is greater than 0, and hence you accept the project. If you calculate the IRR for this set of cash flows, you can try it in an Excel. You get the IRR as 8.21%. What is our discount rate? Discount rate is R. R is less than the IRR. You accept the project. If your discount rate was 9%, or for that matter, even 8.5%, you would have seen that NPV would have turned negative. If your discount rate was greater than the IRR, you would have had to reject the project. Right now, these are simplistic understandings of the IRR and the cash flows that we are looking at, and NPV parameters. There are some nuances to this which we will cover in following videos and sections with some complicated cash flows that come up, right? But this is the broad gist, that if NPV is greater than 0, you accept the project. If your cost of discounting or the cost at which you're raising money is less than the IRR, you accept the project. Both of these technically correspond to the same region for a particular firm, right? Let's try and plot this, right? So let's look at another set of cash flows where you invest about 4 lakh rupees, and for 10 years you're going to make this set of cash flows for your firm. The discount rate is 10%, right? So we have to calculate the NPV at 10%, and then we are going to use Excel to plot this in a chart, right? We are going to create a chart with various discount rates. Fair enough, various discount rates versus NPV at all those discount rates, right? So let's go to an Excel file and try and sort this there. So this is the question that comes to us, that your initial set of cash flows is minus 4 lakhs, and then you make all these cash flows that come here, right? You can do it both the ways. Let's try it both the ways. We take the cash flow and we discount it with the given discount rate, freeze the discount rate, raise to the power the year in which the cash flow is happening, right? And you get this entire set of data that is available with us, and you calculate the NPV, which is the sum of all these values plus the initial inflow, which is 3132, right? At 9%, NPV increases. At 11%, NPV goes down, negative. At 10%, you should be taking the project. So it seems logical that the IRR is somewhere between 10 and 11%, right? Now that's the broad crux that we have identified so far. We could also do the calculation using the NPV function, where we take the rate, we take the set of cash flows starting end of year 1, and we add the initial cash flow to that, and we get the same value, 3132, right? Now we want to plot it at various rates. So let's say we put rates here and we put NPV here, right? And let's say the rates are like 8%, and we keep adding 0.2% to that, 8.2, and so on and so forth. Let's say we want to plot till about 12%, right? So we want to plot the data till about 12%, and we'll see how it makes sense. NPV at this point of time, we can link here. So if you remember, this is similar to your sensitivity analysis with one parameter. I can select this entire data set, click on data, data what if analysis, data table, and there's no row input cell. There's only one parameter, which is column input cell, and I link that to the rates. Click on OK, and we get all the NPVs. Right? We get all the NPVs available to us, and let's kind of quickly reformat these so that they're easy to read. We realize that somewhere between 10.2 and 10.4% the project gets rejected, right? So the IRR should be somewhere between these two parameters. If we want, we can quickly calculate the IRR of this project as well, and that should be between 10.2 and 10.3%. Let's add, that's what we get as the IRR, which is 10.21%. I will put it here as the IRR of the project, correct? So we get the IRR, which is 10.21%. At exactly 10.21% here, we will see the net present value becomes close to 0. And what we're getting here is essentially because of the rounding error. This is 10.207%. If we keep adding decimal points, we'll keep getting closer to 0. If we add one more, this is 2065. So if I change this to 2065, we reach very close to 0, right? That's the IRR concept for us. Let's go back to our initial state where we were at 10%. And now let's try and plot this. So we will select this data. We can insert a line chart, right? The line chart obviously plots both the series there. We don't want the percentages as a series. We want the percentages as a horizontal axis label, right? So select data, and series 1 is the blue one, which we don't need. So we can remove this, edit the axis label range, and select this as the axis label. Click on OK, and we can also go and rename the series here and call it NPV, and click on OK. Click on OK. We get our chart created, right? I'll do some more changes here. Format the axis. I want the axis so that it gives me the axis option, and the labels are low. They are not next to the data, and then I can select one of these parameters here, which kind of displays it slightly better. I can, if I want, remove the legend here, and that's what the chart shows us, right? Now, this is nothing but a sensitivity analysis of the NPV of the project versus the IRR that is available, or versus the discount rate that is available, right? So if you do this, that's the plot that we eventually end up getting. Now, what is the point here that we are trying to make? This is the rate, which is known as the IRR at discount. And so you're plotting the rate here on the x-axis, and you're plotting the NPV here on the y-axis, right? At rates below the IRR, which is on the left side, this entire portion is rates less than the IRR. This is where your project gets accepted, right? Because this is also the place where NPV is above 0, right? These are the points where NPV are above 0. On the other hand, you find on the right hand side uh, the scenario where your rate is greater than the IRR. This is the point where NPV is negative, and this is the rejection zone. Reject the project here. So at any borrowing rates or cost of borrowing for a particular project at less than 10.21%, you accept the project. Anything beyond that, you reject the project. That is the beauty of an NPV IRR plot, that it very clearly demarcates and tells us what is the point where you kind of break even on the project. So effectively, IRR is also the rate. If you borrow at this, that's in a sense your break even point, right? You need to borrow below the IRR. This is the maximum return that you can generate with this set of cash flows. this is the maximum rate of borrowing that you can do, because if you borrow at any rate higher than that, you're going to lose money on this project. Does that make things clear? So that's what is the broad context of NPV and IRR put together. This is for a very, very simplistic project that we have seen. We'll do one more exercise on this, where we'll take an example, and let's say your company kind of spends 10 lakh annually for electricity at its Delhi headquarters. Another company A offers to install a new computer controlled lighting system that will reduce electric bills by rupees 90,000 in each of the next 3 years. If the system costs rupees 5 lakh fully installed, is this a good investment? Now, logically, to the naked eye itself, you are putting in 5 lakh and you're going to get 90,000, 90,000, 90,000. So that's 2 lakh 70,000. The payback period will not work, surely. So this is going to be a bad investment immediately it is available. But let's also try and find out, assuming a rate of return of 8%, what is going to be the NPV. So we find the discount rates, we find the discount rates here, and we discount this as well. And what we find is the NPV is about minus 2,68,061, right? Which practically means that the sum of these present value terms is the difference that we are getting, approximately 2,31,939 is what we're going to get. If we add these two, we'll get 5 lakhs, right? So that's the PV of cash flows that you're getting, or cash inflows, right? Cash outflow present value is minus 5 lakhs. The next question that comes to us is, how much would you be willing to pay for it then? Which logically comes back to our previous example and previous discussion that we have seen, is that if this is the present value of all these cash flows that we are looking at, then at all practical purposes, the maximum that you would be willing to pay here would be 2,31,939. That's the maximum payment you will do, right? So instead of 5 lakh, if you put 231,939, your NPV will become 0, right? If you are able to pay anything lesser than this, so your payment structure is less than 231,939, assuming everything that is there. If you pay anything less than this, then the project gives you a positive net present value, and that is when you would accept the project, right? So these kind of problems are fairly common in businesses, where you have to figure out what is the maximum payment that you have to do for something, what is the amount of time that you're going to take in terms of getting return on your investment, what is going to be the maximum rate at which you can borrow money for a particular project, so that you're still finding the project feasible for you, right? This, however, as we have said time and again, considers only the basic premise of net present value calculations. There are complications and difficulties when you apply these rules in certain specific cases. All those we will discuss in subsequent sessions at a later point of time. At this point of time, this suffices for our discussion on NPV and IRR.